Hi, this is Dr. Mercola, and today I'm joined by Dr. Don Huber, who is an expert in an area of science that relates to GMOs, and it's going to help us understand some of the nasty insider tricks of what's going on with this GMO issue. And he's actually gotten quite a bit of notoriety for his expertise in this area. So welcome, and thank you for joining us.
Thank you, Dr. Mercola.
I'm wondering if you can tell our viewers what your specific training is and how you came to attain this knowledge and information on this very specific area of GMO toxicity.
My area of training is soil-borne diseases, microbial ecology, and host-parasite relationships, so that in realizing that agriculture is a system, not just a bunch of little blocks that fit together, you have to understand how that system works and realize that any time we change one part of that system, we really change the interaction of all of those other components as they work together. And so each time we have a change, whether it's crop rotation or tillage or different fertility programs or herbicide interactions, we see those changes as they affect those components in the system. And so my research over the last 55 years has been devoted to looking at those changes and how we can change them and manage that system for more effective crop production, better disease control, and improved nutrition and safety of our food crops. So when we look at such a major change as you have in a genetic disruption from a genetically engineered process, as we understand it in our limited knowledge now, we see that there are opportunities and actual changes in all of those components as they fit into the agricultural system, from the plant, the physical environment, the dynamics of the biological environment, and of course our pests and diseases as they interact together. So those have been the areas of my research over time and brought me to this point.
And let's just go back a bit into your background. Now you currently live in Idaho, or were you raised in Idaho?
I moved to Idaho in high school with our family. We moved the dairy up from Arizona.
So your parents were dairy farmers?
Parents were dairy farmer, raised on a dairy farm. I was at the University of Idaho as a professor for 8 years before going to Purdue University, and we were there on staff as a professor for 35 years. And
what did you teach at Purdue?
I was plant pathology, soil microbiology, those microbial ecological interactions as they relate to plant disease.
And I'll just review my understanding, and you can modify that as we go along. But I suspect your expertise in this area is related to the fact that one of the major modifications that are done in GMO crops is, by Monsanto primarily, is to provide an herbicide resistance against a pesticide, the most common pesticide used in the U.S. and I suspect the world, which is Roundup, which is also a glycophosphate pesticide, I believe. So as a result of that, they're able to essentially kill the weeds and more efficiently or cost effectively produce crops, and supposedly at a lower price. I mean, that's the working premise. That's a whole other issue whether or not that's true. But what I'd like you to comment on is how that introduction of that resistance, which allows them to display massive amounts of this very toxic glycophosphate pesticide into the environment, how that impacts the soil microbes. Because one wouldn't think that it would affect it, not necessarily because it's an herbicide, which is directed towards plants, not necessarily animals or bacteria even. But apparently it does, and I'd like you to elaborate on that, because you've found some really interesting observations.
Well, what you have to do is realize what an herbicide is, or most of our pesticides, that they're metal chelators. In other words, they're able to immobilize specific nutrients. And that's how they perform their function as a pesticide, is by immobilizing an essential nutrient that is required as kind of that key to for a specific enzyme.
Do they work on a variety of different mineral chelators, or there's one or more that they target specifically?
Most of our pesticides, herbicides, are quite specific. For instance, if you look at phenoxyprop or tordon, those will be copper chelators. In other words, they're specific for a particular copper relationship. By chelator, we mean it's a compound that can grab on to another element and change its either solubility or its availability for that critical function that it has physiologically. So that we have those herbicides and pesticides that are quite specific for just a particular essential micronutrient like copper or zinc or iron or manganese. Glyphosate is very unique in that it was first patented as a chelator by Stauffer Chemical Company in 1964 because it could bind with any positively charged cation. And so if you look at the essential minerals for plants, you see calcium and magnesium, potassium, copper, iron, manganese, zinc, all of those other critical transition elements as well as structural components for the some of them. But you see that they're all cations. Now they have an anion that is associated with them, but it's the micronutrient that's a cation that is the transition element, or that element that really is critical for a particular enzyme function. So if you can chelate, and in that chelation process essentially immobilize that essential nutrient, you have provided an opportunity to either kill a weed or damage and kill an organism. So that any organism or any weed or plant that would have that particular requirement for that physiologic pathway with glyphosate, the shikimate pathway, then you have an opportunity to have a very effective herbicide. You have to realize, though, that mode of action is immobilizing a critical essential nutrient. Those nutrients aren't just required by the weed, but they're required by microorganisms. They're required by us for our own physiologic function. So if it's immobilized, it may be present if we do a regular test, but it's not necessarily physiologically available in the same efficiency that it would have been if it wasn't chelated with that glyphosate or other chemical chelator.
Yeah, for those who aren't familiar with a chelator, it just means it's complexing, and this when it's complex to these essential minerals, it essentially forms a barrier around it which prevents whatever life form is seeking to utilize that element from utilizing it properly. So I'm wondering if it's an artifact or a side effect of glyphosate to affect the bacterial organisms in the soil that you're an expert at. Because this seems to be, it wasn't designed as part of it. It's just sort of a side effect that they hadn't anticipated. Does that seem to be the case?
Well, again, any organism that has those same physiologic pathways is going to be impacted the same. What you need to remember, though, in the genetic engineering process, there's nothing in the technology that does anything to the chemical that's applied. All it does is insert another gene that makes it possible for you to apply that chemical directly to the plant without damaging that particular plant. The glyphosate is still, even in that herbicide-tolerant plant, that Roundup-ready plant, the glyphosate is still having an impact on 25 or 26 other enzymes because it's also chelating or immobilizing critical micronutrients, those cations, that are required as the keys to turn on those physiologic engines that make that organism or that plant really function. So in the technology, in our genetically engineering technology, we do nothing to reduce the chelating ability. We only provide an alternative pathway for that plant to survive the application of this toxic chemical being applied to it.
Would it be fair to assume that because that plant doesn't have access to those critical nutrients, that other metabolic pathways are impaired, and as a result is not going to be able to provide the same type of nutrition to the end consumer who is consuming that plant?
Well, this is well documented, that the nutritional efficiency, just having that foreign gene inserted, reduces the capability of that plant to take up nutrients and to translocate nutrients. Then when you apply the chemical, you have a further compounding effect in reducing the efficiency of the plant, so that at rates as low as a ½ ounce per acre, 12 grams per acre, been demonstrated that you reduce the uptake and efficiency of iron by 50%, of manganese, critical for liver function and immune response, by 80%. But then when you look at translocation from roots to shoot, you also have a reduction in zinc and all three of those critical elements of 80 to 90%. So greatly compromised nutritional efficiency, as well as the ability of that plant to accumulate and to store those nutrients for its own use, but also for us and for our animals' nutrition in that process.
Well, thank you for pointing that out, because my impression is that most people who even are moderately familiar with GMOs tend not to fully appreciate what you just said. And it's a really important concept, that somehow they think that when it's a genetically modified food, they're somehow magically more efficient. And they don't understand that this application of the pesticide has this complication on the plant itself, which impairs its own nutrition, but doesn't magically disappear. It's that pesticide is still loaded in the plant. So that not only are you getting a compromised plant from a nutritional quality perspective, but you're also getting toxic residues of the very herbicide that was used to provide supposedly a more efficient and more cost-effective plant. So that you're compromising your own health. And then there's this whole other component that you're getting the genetic modification itself, which is inserted into the gene, which has been shown in a number of animal studies to have complications such as decreased fertility. So it's just a panoply of problems.
You know, glyphosate, of course, very unique also in that it's systemic in the plant, so that it accumulates in those growth points.
So it's not just on the surface.
No, that's going to be within the plant. It's going to be in your...
You can't wash it off.
No, it's going to be in your root tips, your shoot tips, your legume nodules, and in the food that we eat, because it's in those reproductive structures.
Wow.
That's where it accumulates. And the later it's applied, now that they're using glyphosate as ripening agents to kill the plant before, to kind of speed up that harvest process, the only place that it can go is right into the seed. Now about 20% of it, though, moves out of the roots. So it moves down out into the soil, where it has the same effect on many of those beneficial soil microorganisms that it has on weeds, because they have that same critical essential metabolic pathway. But our residue levels are increasing. Every time we have a new Roundup Ready crop approved, we also see an increase in tolerance levels in the crop.
Now, we could end the interview here now, because I think you've just given us enough information to get more excited about the process of becoming an activist to eliminate this threat to our food supply. But what I'd like you to comment, because you've got a lot more information, what I'd like you to comment now is on which is your area of expertise, and how this pesticide or herbicide influences the microbial organisms within the soil. And you certainly understand this at a very deep level, and I think many people do, but many don't, and that is that the quality of the food is almost always related to the quality of the soil, and the most foundational, vital, critical components of the soil are the microorganisms that are thriving there, rather than necessarily the nutrients, because it's the microorganisms that allow the plants to utilize those nutrients. So I'm wondering if you can comment on that.
Well, the plant can only utilize certain forms of all the nutrients. For instance, with manganese and with iron, it has to be in a reduced form. And the way that becomes reduced in the soil is through those beneficial microorganisms. We also have those microorganisms for our legumes like soybeans or alfalfa or peas, any of the other legumes that can fix up to 75% of their actual nitrogen for protein and amino acid synthesis actually comes from the air through those microorganisms in the soil. Glyphosate is extremely toxic to all of those organisms. So what we see with our continued use and abuse of this powerful pesticide or powerful weed killer is that it's also totally eliminating many of those organisms from the soil. We no longer have the same balance that we used to have, and consequently we see an increase of over 40 new diseases, or 40 diseases that we used to have managed or under fairly effective control, that all of a sudden are another serious problem for us.
And these are plant diseases.
These are plant diseases. But the other thing we see is that the normal biological control organisms, even in the animal, are very sensitive to those residual glyphosate levels. I was just reviewing a paper as I flew out here yesterday on a chronic botulism or toxic botulism type problem. This is where you have the Clostridium botulinum in the intestinal tract. It's a common soil organism everywhere. But all of a sudden we're seeing cases now, especially in dairy, but other situations where the animals are dying and becoming impaired from the botulism toxin from the Clostridium in the intestinal tract and stomach and rumen, where that normally didn't occur before because you had all of those organisms that provided the natural biological control. In this paper, what they show is that residues that are of glyphosate that are permitted in our feed and food products are high enough to kill those normal biological control organisms, your lactobacillus, your alkaligenes, a number of those organisms, very effective in preventing the toxin production by Clostridium, that those organisms are eliminated by the glyphosate levels that can be in our food and feed supply, so that then the animals suffer the same effects as though we'd put them under or given them a treatment of this very intense biological warfare chemical that is produced naturally in the intestine without that balance again. Again, agricultural system, as well as our own ecology, is really a balance. It's a system, not just a bunch of silver bullets that are stacked up in the revolver or chamber of a revolver. But